Now let us see the derivation of how to find the distance of origin from any given line. So in this figure we have considered any general line with the equation as ax plus by plus c equal to 0, and the perpendicular distance ON from the origin is denoted as d. Now here if you consider the general equation of the line, then we know that the coordinates of point A, which represent nothing but the x-intercept of the line, right? And we have seen that the x-intercept is given by minus c by a. So minus c by a comma 0 are coordinates of point A, and 0 comma minus c by b are the coordinates of point B, which indicates the y-intercept of the line. Now to find out the distance from the origin, we use one important idea, that the triangle OAB, as we can see in the figure, can have its area calculated by two different ways. That is, first of all, we can write area of the triangle AOB as equal to half into OA into OB, right? So that turns out to be half into OA is nothing but minus C upon A. But here we have to be careful, because minus C upon A could be positive or negative, and while calculating the areas we want OA and OB as the distances. So therefore we will not write as purely minus C by A, but we will write them under the absolute sign, right? Similarly, OB can be written as mod of minus C by B, right? So therefore by multiplying we get, since minus C and minus C, which are under the mod, they can be squared, and square is always positive. So therefore that will give us C square divided by 2 into mod of AB, because we don't know whether the product AB is positive or negative, right? So that is the first expression for getting the area of the triangle. Now we can write the area of the triangle in a different way also. That is, we can write area of triangle AOB as, if we consider AB as the base, you see this distance AB as the base, then ON, that becomes the height, correct? So therefore we can write half AB into, let us write it as D, which is what we want to find out. Okay, now let us get an expression for AB, and to get AB we can use the distance formula for points A and B. So that gives us minus C by A minus 0 the whole square plus 0 minus of minus C by B gives us 0 plus C by B the whole square, right? So therefore that turns out to be C square upon A square plus C square upon B square. So that turns out to be, taking C square common, we have 1 upon A square plus 1 upon B square, okay? And hence on cross multiplying and taking the roots outside, we get final answer as mod C by AB into root of A square plus B square. So therefore substituting this value of AB in the second expression of area that we just calculated, we write it as half mod C by AB into root of A square plus B square into D, right? So therefore we equate these two areas that we have got, right? So therefore we can write half mod of C by AB into root of A square plus B square into D is equal to, of course this D is separate, it's not inside the square root, that is equal to C square upon 2 into mod of A into B. So therefore 2 gets cancelled from both sides, mod of AB also gets cancelled from both sides, mod C gets cancelled from both sides, okay? Therefore finally we get D is equal to, since on the right side it was C square, now we can't write just c on the right side, but we have to write it as mod c, and hence we write it as mod of c divided by root of a square plus b square. So that is the formula for getting the perpendicular distance of origin from any given line whose general equation is known. So it's important that the equation of the line is given in general form only, and if it is given in any other form, then we have to first convert it into the general form, because a, b, c are the respective coefficients in the general form. Now with the help of this derivation we can generalize it and derive an expression for distance of any point from a given line, right? So instead of origin, it can be any point whose perpendicular distance d we want to find out. Now to do that, what do we do is basically we do the shift of origin from the original origin, that is 0, 0 to the point x1, y1, right? So what it means is, we know that by shift of origin we can write x is equal to capital X plus h and y is equal to capital Y plus k, where x and y are the old coordinates, capital X and y are the new coordinates, and h and k are the coordinates of the new origin, correct? So therefore we can write the equation of the line as a into bracket capital X plus h plus b into bracket capital Y plus k plus c is equal to 0. So therefore on simplifying we get ax plus by, correct? We get these terms, plus the remaining terms we write as ah plus bk plus c is equal to 0. That is a into h plus b into k plus c. Now h and k basically are nothing but the coordinates of our new origin. So in this case they are nothing but x1, y1. So therefore we can replace them as ax plus by plus, in place of h we write x1, then by1 plus c is equal to 0. So if you look at this final equation, it also represents the equation of the same line but with the new coordinate system. So therefore this bracketed term becomes the constant term in the new coordinate system, and hence now if the origin is at now x1, y1, the distance d is given by, if you remember the formula which we just derived, it has the constant term in the numerator, but the constant term here is ax1 plus by1 plus c, right, divided by root of a square plus b square. So that's the generalization of the previous result, and this is a very important formula. We need to use it in many different topics. So that's the distance of any point from any line on which of course that point does not lie. The simple way to remember this formula is, if you look at the numerator, right, the numerator is nothing but merely the left hand side of the equation of the line in which x and y are substituted with the x and y coordinates of the required point. So that's the way to remember the formula. Now let's solve one simple example based on this result. Find the distance of point -4, 3 from the line whose equation is given. Now if you observe the equation, it is not in the general form, right? So we have to first convert it into the general form. So therefore let us simplify. We get 4x plus 20 is equal to 3y minus 18. So therefore bringing all terms on one side, we have 4x minus 3y plus 38 is equal to 0. So we have got a general form of the equation and the point is given. So therefore let us write the formula for the distance of a point, that is ax1 plus by1 plus c whole divided by root of a square plus b square. So therefore substituting the values, we have 4 into bracket. You see where you have x you put minus 4 and where you have y you put 3. So we have 4 into minus 4 minus 3 into 3 plus 38 divided by root of 4 square, which is a square, plus minus 3 the whole square, which is b square. Okay. So on simplifying that further, we get mod of minus 16 minus 9 plus 38 divided by root of, we have 16 plus 9. That gives us, in the numerator we have 38 minus 25, which is 13, and divided by root of 25 is 5. So now since it's a distance, we take only the positive value, that is 13 upon 5. So that's the distance of the given point from the given line.